Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about factor and the remainder theorems. See the factor and remainder theorems, okay? So let's say we're given a function 3x cubed minus 5x squared minus 9x plus 8. You're being asked to divide it by x minus 1, okay? So let's just do synthetic division. So the in-house number here will be 1 because x minus 1 is equal to 0 plus 1 there will be x equal to 1. We all know that. And the coefficient or the dividend is already in standard form. So I can write 3, negative 5, negative 9, 8. And there's no missing power for a term. Applying synthetic division here, we're going to drop the 3. 3 times 1 is going to be 3. Negative 5 plus 3 is negative 2. Negative 2 times 1 is negative 2 minus 11. Negative 11 times 1 is negative 11. This will be negative 3. And we know that the answer here will be 3x squared minus 2x minus 11 minus 3 over x minus 1. And we know that the remainder here is negative 3. Okay, remember that. And let's find f of 1. Okay, we're gonna we're gonna plug in the 1 to the x value there and evaluate it. Okay, so that will give us f of 1 is equal to 3 1 cubed minus 5 1 squared minus 9 times 1 plus 8. You can use your calculator or you can do this manually. Let's try to do it manually. 1 to the third is 1 times 3 is 3. 1 squared is 1 times negative 5 is negative 5. 9 times 1 is negative 9 and plus 8. 3 minus 5 is negative 2 minus 9 plus 8. Negative 2 minus 9 is negative 11 plus 8 will give you negative 3. So f of 1 is equal to negative 3. Do you notice anything same or similar here? We can, if you see that the remainder here is negative 3 and the f of 1 is equal to negative 3, and you're correct. Meaning to say, x minus 1 here, wherein we got a value of in-house of 1 and the f of 1 meant the same thing. This is where the remainder theorem comes along, okay? So the meaning of the remainder theorem here is that when you divide a polynomial by a binomial x minus 1, whatever the remainder there, it will be the same value when you evaluate the f of 1, okay, or f of a, okay? Let's apply the remainder theorem here. So use the remainder theorem to evaluate f of x at c. So the value of c here is negative 2. So if we find f of negative 2 here, it's going to be negative 2 to the third power minus 7 negative 2 squared plus 6 times negative 2 minus 10. Negative 2 to the third power is negative 8. Remember, guys, you're going to square it first here. Negative 2 squared is positive 4 times negative 7 is negative 28. 6 times negative 2 is negative 12 minus 10. That will give us negative 8 minus 28 is negative 36 minus 22. And that will give us f of negative 2 is negative 58. The meaning of that, if we use synthetic division and we use negative 2 as our in-house number, we should get a remainder of negative 8. Let's do it. So 1, negative 7, 6, negative 10. Let's use synthetic division. We're going to drop the 1 here. 1 times negative 2 is negative 2. This will give you negative 9. Negative 9 times negative 2 is positive 18. 6 plus 18 is going to be 24. 24 times negative 2 is negative 48. Negative 10 minus 48 is negative 58. And we know that the last number there represents our remainder, which is the same thing when we evaluate f of negative 2. And that shows us the remainder theorem. Why do we need to do that one? Because it's easier than doing long division, and it matters what is the remainder. This is where the factor theorem comes along. If the remainder is equal to 0, then the divisor or the binomial, x minus c here, is a factor of the function. Otherwise, if the remainder is not equal to 0, then that divisor or binomial is not a factor. Okay, so if you look at this example here, if the remainder is equal to 0, then that in-house number, which is f of negative 4, would that x plus 4, remember that is x plus 4, that x plus 4 is a factor. Okay, so let's go ahead here. Let's use this example. Use the factor theorem to determine which binomial is or are factor of the given function. So I have here f of x, 4x cubed minus 3x squared minus 9x minus 2, which among these three choices here possibly could be a factor of the given function. We will use the factor theorem to determine that one, and we're going to use the concept of synthetic division or remainder theorem to know the answer. Okay, we'll do both. Okay, so let's try letter A. So x minus 1 here, the value of x there is equal to 1. So therefore, let's do remainder theorem. F of 1 is equal to 4, 1 to the third power minus 3, 1 squared minus 9, 1 minus 2. So 1 to the third power is 1 times 4 will give me a 4. 1 squared is 1 times 3 is negative 3. Negative 9 times 1 is negative 9 minus 2. So 4 minus 3 is 1 minus 9 minus 2. That will give me minus 8 minus 2. F of 1 is equal to negative 10. So therefore, letter A is not letter A is not a factor of the given function because it's not equal to 0. Okay, let's try letter B here. Let's try letter B. So for letter B, let me try use remainder theorem again, f of negative 1 this time. Remember, this is x plus 1 here. When we set it equal to 0, we have to solve for the x by subtracting 1, subtracting 1. That's why the value of c there will be negative 1. So plug in 4 times negative 1 to the third power minus 3, negative 1 squared minus 9, negative 1 minus 2. So negative 1 to the third power will be negative 1 because negative times negative times negative, that will become negative, times 4 will become negative 4. Negative 1 squared is positive 1 times negative 3 is minus 3. Negative 9 times negative 1 is positive 9 minus 2. Negative 4 minus 3 is going to be negative 7 plus 9 minus 2. Negative 7 plus 9 is equal to positive 2 minus 2 is equal to 0. So therefore, f of negative 1 is equal to 0. So therefore, x plus 1 is a factor. So I'm going to write here, x plus 1 is a factor, right? Because the remainder, using remainder theorem, it's equal to 0, okay? That's how you apply remainder theorem for that one. And the factor theorem. What can I use synthetic division? Yes, you can. Let's do letter C. Let's try letter C. So right now we know this is wrong. It's not going to be a factor. B is a factor. So let's try x minus 2. Remember, x minus 2 is equal to 0. So therefore, plus 2 there, plus 2 there, x equal to 2. So applying synthetic division, my in-house number is 2. Using synthetic, I will have the coefficient here. They are already in standard form. Drop the 4. 4 times 2 is 8. Negative 3 plus 8 is 5. 5 times 2 is 10. Negative 9 plus 10 is 1. 1 times 2 is 2. 0. So the remainder there is equal to 0. So therefore, x minus 2 is a factor. Kaboom. Next. Factoring and finding zeros. Okay, so use the factor theorem and the given binomial to complete the polynomials, then find or give the zero. So here we have f of x equal to 4x to the fourth minus 7x cubed plus 2x squared plus x. You're given x minus 1 here. X minus 1 is a factor, okay? Then we have to find the rest of our rest. Here we're given a function f of x equal to 4x4 minus 7x to the third plus 2x squared plus x. And the factor that's given is x minus 1. Remember, guys, that we have 4 as our degree of the function. So fourth degree, if they have fourth degree, how many zeros do we have? There should be 4 zeros here, okay? But you can see already that 4x4 minus 7x cubed plus 2x squared plus x has something in common. What's common to them? They all have x's. So I can factor out the x there, and that will give me 4x cubed minus 7x squared plus 2x plus 1. That tells me that one of the factor is x minus 1, which is the given, and this x here is another 1. So now I can focus myself on this one here, okay? All right, so we have 4x cubed minus 7x squared plus 2x plus 1. Now, the degree here is a third, so we need to find 3 factors here, okay? So how do we find 3 factors, or 3 zeros, I mean? We have to find the 3 zeros here. So how do we do it? We're going to use synthetic division based on the given binomial here, x minus 1, okay? So I'm going to use synthetic division here. The in-house number here will be positive 1 because of the x minus 1. This will give me a 4, a negative 7, a 2, and a 1, right? So I'm going to drop the 4. 4 times 1 is 4. Negative 7 plus 4 is negative 3. And 1 times negative 3 is negative 3. 2 plus negative 3 is negative 1. Negative 1 times 1 is going to be negative 1. And the remainder is 0. So therefore, it proves that 1, the in-house number, or the x minus 1, is a factor, right? So what's left with us here? We have here 4, negative 3, negative 1. What's the meaning of that one? The 4, negative 3, and negative 1, remember, that is your quotient, and it's always 1 less. So it's going to be x squared minus 3x minus 1 is equal to 0 now here. And remember how to do big boy factoring. If we only have a square there, we can do big boy factoring by multiplying 4 by negative 1. X squared minus 3x minus 4 is equal to 0. Factor that one the regular way. We know what two numbers, when you multiply them, will give you a negative 4. When you add them, will give you a negative 3. So that is going to be positive 1 and negative 4. And then don't forget to divide it by 4 because you multiply the 4 in the beginning. And we cannot work out the 1/4 anymore. That's the lowest term we could have. So I'm going to bring it up, 4x plus 1. And 4 divided by 4 is x minus 1. So therefore, guys, my complete factors are x minus 1, x, 4x plus 1, and x minus 1. Okay? Now, we're being asked here to find the zeros, complete the zeros here. How do we find the zeros here? Based on our factor, we have x minus 1 equal to 0. We have x is equal to 0. We have 4x plus 1 equal to 0. And so happen that x minus 1 is equal to 0, which is the same thing as that one. So I don't really have to write this out. Solving it out, plus 1 here, plus 1 there. That gives me x equal to 1 with a multiplicity of 2, because there are 2 of that. X equals 0. And minus 1 minus 1, 4x equal to negative 1, divide by 4, divide by 4. So x equal to negative 1/4. And those are your zeros. 1 with the multiplicity of 2, 0, and negative 1/4. And that's how you apply the remainder and factor theorem and finding zeros. And as always, kaboom!